Hi, I'm Salman. Welcome to Rebioin AI, and today we will discuss the topic Intro to Deep Learning. Before I begin this video, I will give you a small introduction telling what exactly deep learning means with few simple example to make understand in simple manner. Firstly, let me give you a small example. Imagine teaching a child to identify a cat. Simply, you won't give a description of cat to the child telling cat has features such as it has 2 ears, 4 legs, a tail, and whiskers. Simply telling these features to the child about cat, the child won't understand what cat looks like. Instead of doing this, you will simply show thousands of images or multiple images of cat to the child. Eventually, based on these images, the child learns what cat looks like, right? And similarly, the deep learning also works in the same way. It learns from patterns automatically from lots of data. And where can we see this deep learning involvement? We can see this deep learning in face lock features in mobile, in ChatGPT, Google Translate, self-driving cars, and in fine and medical image diagnosis. Today in this video, I will cover 5 modules telling everything about deep learning. Firstly, we'll discuss about neural network basics, then TensorFlow Keras, CNN for images, NLP basics, MLOps basics. Let me begin with machine learning versus deep learning difference because many are confused. In machine learning, it needs manual feature selection, but whereas in deep learning, it learns features automatically. On the other hand, machine learning it works well with small data set, but deep learning it requires large data set. In machine learning the training is very faster, but in deep learning the training is very slower. In machine learning it uses algorithm like decision tree, but whereas in deep learning it requires neural network. So firstly we'll begin with neural network basics. So what exactly is neural network? So imagine a neural network is inspired by the human brain. Our brain contains billions of neurons, right? Similarly, a neural network contains artificial neurons. If you give input, it goes through neurons, and finally, from this neuron, you'll get an output. Many neurons together form a network. So it occurs in 3 steps. Firstly, input layer, then hidden layer, and finally the output layer. The input layer receives data, hidden layers learn pattern, and finally layer gives the prediction. And now we'll see about perceptron. What is a perceptron? A perceptron is the simplest neural network. For instance, imagine deciding whether to carry an umbrella. You'll give multiple inputs to the perceptron. Inputs such as whether it is raining, you'll give yes. Are the clouds are there? Yes. You will tell it is present. And finally, the last output, if you give wind, there is no. Based on all this input, it combines these inputs and finally it gives an output telling you to carry the umbrella or not. And perceptron also it weights or it gives priority of all the inputs. It ranks these inputs. So first, if you give the first input raining, yes, it ranks this as the high priority. W1 it has given the most weight to this input and so on. And for cloud it has given second priority. Based on all these inputs it gives the final output. A single perceptron can only draw a straight line. So if you stack all these inputs, it gives the complete neural network. And next we'll discuss about activation function. After calculating the weighted sum, the neuron decide whether to activate. Without an activation function, everything would behave like a straight line. Individual perceptron are there already there, right? So all this perceptron combines and it forms the neural network. So the perceptron it gives output in linear straight line, but by using activation function it introduced non-linearity. Thus neural networks couldn't learn complex problem without activation function. There are several common activation functions. I have included 4 here. such as activation functions such as Sigmoid, Tanh, ReLU, and Softmax. All this activation function has their individual use in based on different necessity. Firstly, we'll see about Sigmoid. In Sigmoid, the output is always between 0 and 1. And where is this useful in? It is useful in yes or no prediction, disease prediction, and so on. And Softmax. Softmax used where there are many classes, such as example, if you give a prediction, if you give image, based on based on this image, there may be different results, such as the image may be the image of dog, cat, or horse. In the image, it gives the ranking, whether the image is cat, it'll give you a value or output telling the giving the value of this image. Dog is equals to 0.05, cat is equals to 0.90, and finally horse is equal to 0.05. It has given this number. So which has the highest number? Cat. It has given the value of 0.90. So this value, it tells the image is highly probable that it is cat. So here the highest probability wins. So this is all about activation function. I have listed 4 activation function here. Next we'll move with backpropagation. I will give you a simple example what exactly backpropagation means. This is nothing but this is a method how neural network learns. We'll take a simple example. Think of a student taking a test. Just there is something like prediction. So student has predicted 80% in a question, but the actual answer was 100. So there was an error, right? The prediction was 80 and the actual answer was 100. The student made the error of 20. And teacher says you made a mistake, and based on this the student studies more and improves. And exactly as this the neural networks do exactly, it learns from its mistake. So firstly it gives prediction, then based on the actual value it calculates the error and adjusts the weight, and again it predicts, then finally it does the repetition. This repeated learning process is called the back propagation. This is the method of learning. Next we'll move with TensorFlow. TensorFlow is a deep learning library. It is developed by Google. What does it exactly do? It provides ready-made tools for building neural network. Instead of writing everything from scratch, you simply give an instruction and it handles the complex calculation. Whereas Keras, there is a huge difference between TensorFlow and Keras. Keras is a high-level API that runs on TensorFlow. To differentiate this, I will just say TensorFlow is like your car engine and Keras is like your steering wheel. Keras makes building neural network much easier. You can check out TensorFlow in Google. Next, we'll move with building your first ANN. ANN stands for Artificial Neural Network. This is the whole flow of ANN in 5 steps. We'll take a small example here. There is a prediction whether a student passes or fail, and if you give multiple outputs like hard studied, attendance of the student, assignment of the student, and finally based on this inputs it will give final output whether the student pass or fail. So this is how it works, giving output, and based on this outputs it will give a based on this input it will give a output. So firstly, to building your first ANN in 5 steps, first you have to collect the data, then import this data, and you have to give a defined model, how it should work, and compiling all this. And next you have to train the model. Finally, if you do all this, it evaluates and predicts. Next we'll move for CNN for images. CNN stands for Convolutional Neural Network. New CNN is the special designed for images. So where can we see this CNN application? It is seen in face. recognition, MRI scan analysis, object detection, and number recognition. Instead of seeing the entire image at once, CNN looks at small parts. As I said earlier, in face recognition. So, how it works? Suppose you give multiple images or out inputs to the deep learning. It recognizes small parts of the image, such as nose, eyes, ears. It recognizes all these features and eventually it tells it is a face of a human. So this is how it works. Rather than selecting all the image at once, a single image, it just breaks in part and it gives a final output. So this is how CNN looks at small parts. You can see here, this is the whole image. It has taken in a part and finally it is calculated. So this is actually for filters. We'll see what filter is. A filter is a small window that moves over the image. So consider this as an image and it is a small window. It moves on the image and it takes this part and gives featured mapper output here. Basically, it detects edges, shapes, lines, and curves. Different filters learn different features automatically during the training. Next, we will move forward with pooling. What does pooling do? Pooling reduces image size while keeping the most important information. For example, take originally you have given four numbers like 2, 4, 5, 8, and after pooling, it just gives a small part of this image without loss of any major data from the image. So you can see here, this is what input you have given here. So only the most important segment is taken from this without compromising in the data. Typically this is the roadmap of how CNN pipeline looks like. So if you give input image based on convolution and ReLU activation, it does pooling. Simply it means reducing the size or making compiling. It repeats this thing again and again, and lastly this image is turned in 2D feature map into a single 1D vector. Then next step is to dense or fully connected combine features into the final decision, and lastly it gives the class probability or output. Benefit of this pooling is we need smaller computation, faster training, less memory usage, and it reduces overfitting. Next, we'll go with NLP basics. NLP stands for Natural Language Processing. It helps computers understand human language. It is seen in different sectors such as different AI models such as ChatGPT, Google Translate, Gmail spam detection, voice assistant, Gemini, and so on. We'll see tokenization in NLP. Computers break sentence into smaller pieces called tokens. Basically, computers don't understand sentence, only it understands numbers. So tokenization is the first step, splitting raw text into smaller units called tokens, such as words or subwords, which can then convert to numbers. Though if you give an input here, sentence, the drug shows good bioavailability. This is the input which you have given here. It is a whole sentence. So what does tokenization do? It breaks or it divides the whole sentence in single words and it processes individually. It has given here, you can see here, it has given the drug shows good bioavailability individual, and subword token, again it breaks these words. You can see bioavailability here. It has divided in three segments: bio, avail, and ability. So this is what it is doing, and based on this the computers can process each word individually. Next we'll discuss about TF-IDF. TF-IDF stands for Term Frequency Inverse Document Frequency. Scores how important a word is to one document within a collection of documents. Example, in a document there are different words like dog, 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 cat. In document 2 we are having cat, fish. Based on this, dog is very important in document 1 because it has appeared frequently, right? And common words like the or is appear in many documents, so TF-IDF gives them lower importance. TF-IDF is commonly used for document classification in search engines and spam detection. You can see over here, if you're having document 1 drug, it has appeared high, document 2 very high, so it gives low appearance. And nanoparticle, in document 1 it has listed multiple times, in document 2 very less, and in document 3 very less, none. So it has given a priority here. You can see here it has given high because it is rare and distinctive. It has given in only document 1, but in the other, on the other hand, in document 2 and document 3 it has mentioned very less. You can see over here the last one, in document 1, 2 and 3 the it has appeared multiple time, and not just multiple, in very high quantity. So it is near zero. It is not a common word, right? Next, we'll see about word embedding. Computers understand numbers, not words. I said earlier, word embedding converts word into numerical vectors while preserving the meaning. You can see a famous example, king, man, plus woman, queen. Embedding capture relationship and analogs, not just word identity, words used in similar contexts. Tablets, capsules get similar vector purely from pattern in large amount of text. For instance, let's see king. You'll give a value or vectors like 0.21, 0.54, 0.89, and similarly queen also you'll give something like 0.20, 0.56, and 0.87. Since king and queen have similar meaning, their vectors are also similar. And few popular embedding method include word to vec, GLOVE, fast text. Modern language models like ChatGPT use much more advanced embedding. And finally, we'll see about MLOps basics. MLOps stands for Machine Learning Operation, is the practice of managing machine learning models after they are built. There is a typical workflow in MLOps basics. Firstly, it collects data, then we train the model, then saving the model, then have to deploy this model. Later, user makes prediction and monitor the update model. It is similar to DevOps but focused on machine learning. Training a model can take minutes to hours. You don't want to return every time. Save the trained model to disk once, then simply load it whenever you need to make prediction. Save and load molecules. After training a model, you don't want to train it every time, as I said earlier. So you just save it in the disk. If you give a clear instruction to the model, it will just save and load all your data. This allows you to reuse the trained model whenever you need it. We'll discuss about Streamlit introduction. Streamlit is the Python framework for creating web application for machine learning models without needing HTML, CSS or JavaScript. Instead of running a model only in notebook, you can create a simple website where user enter data and receive predictions. I will give you a simple workflow. User enters output, then it goes to the Streamlit app, and by machine learning model it predicts prediction shows on the screen. So simply if you give a clear instruction to this, it will give you a perfect output. So this is all about deep learning. I will show you a demonstration using Google Colab. We'll see. Firstly, we'll discuss the complete learning flow. Firstly, we learned about deep learning, then neural network, perceptron, activation function, backpropagation, TensorFlow and Keras, and how to build ANN, CNN for images, NLP for text, and saving the model, and deploy with Streamlit for development. So this is all about deep learning. We'll go with Google Colab. Yes. Without installation of any software, I will just show how it is done without installation by using Google Colab. Firstly, you have to search Google Colab, click on the first one. You see over here, welcome to Google Colab. So this is the one. Click on this. Wait for a few seconds, cancel here. You can see over here, this is the interface which you get once you click on Google Colab. Click on File, click on New Notebook in Drive. Wait for a few seconds. So this is the interface you get. So basically you start your coding here. In this, what you're going to do is you're just simply giving an instruction to this, and based on this instruction it does exactly as you say to it. So first we'll learn about TensorFlow. You want activation of TensorFlow, first you have to give instruction to our Google Colab. Firstly, to start TensorFlow, you are giving instruction to import TensorFlow as TF. Now we have given an instruction to import TensorFlow as TF. So this is what we have given. We have given instruction to Google Colab telling to initiate TensorFlow, and we have given short name as TF. And again we need one more library tool, which is NumPy. So basically NumPy, it is a Python library tool which is used for calculation. It is just a calculation. Think this has calculator which does maths very quickly. You can see here. So I have given instruction to import TensorFlow and given a short name, and to import NumPy as NP. You have two options, whether you can click on this icon or simply you can click shift enter and wait few seconds. If you get the green signal, so it is ready to go. First, what we have done, we have imported required libraries. TensorFlow is used to build and train the deep learning model, while NumPy is used to create and handle numerical data. And this is our first step. We have begun. So we got a green signal. Next, we have to create a data set. I'll create a small data set. So firstly, we'll take X, which represents the number of study hours, and Y represent the result, where 0 means fail and 1 means pass. In this, I'll just show you a goal where we predict whether a student is likely to pass or fail based on study hours. Now let us include our value here. So as I said earlier, X represent the number of study hours and Y represent result. So we'll give our value X equals NP. So this is in NumPy array, a data set. So we have to give in variable format. Will include number of study hours 2, then 4, later 6. If there is a minute or small mistake in the code or instruction, you will get an error, but there is no need to fear, it happens. But we'll go with the last final hour, will take 10 hours. This is what I have given. I have given instruction X is number of hour studies. So this is what I have given the value here. Next we'll take our Y value. Y equals in NP format. We'll give our value here. We'll take 0, 0, 1, 1. We have taken 5 value here. It is done. After this, just simply click on shift. So this is ready to go. This is our value. Next, now we have to build a simple neural network. The first layer has 4 neurons with the ReLU activation function. The final layer has one neuron with the Sigmoid activation function, which gives an output between 0 to 1. So this is what we are going to use. So I will give this instruction here. Model we're going to take is TF, which is TensorFlow. We're going to use here Keras in sequential. We'll click here sequential. We'll include here TF Keras dot layers dot dense. Then we need activation equals, we'll take activator ReLU and input shape and Keras layers. It might be quite confusing because instruction is very long if you give. And finally activation. Yes, this is our instruction. So what I have tell the neural network is to build the first layer as 4 neurons with the ReLU activation, as I said earlier function. The first layer has one neuron with a sigmoid activation function, which gives an output 0 to 1. So let's start. Wait for a second. If you face an error like this, just go with your model. So this is what we are given: sequential. So we missed an S here. Layer stems. So I think yes. So if you just make a small mistake, you'll face an error like this, but no need to worry, just go through once. So we have given our instruction here, we build our model here. Next step is to compile this model. So we'll give we'll give our instruction here. So firstly, model is to compile. Okay, compile. Then optimizer. Optimizer equals, will give Adam here. Adam. Then loss. Binary and cross entropy. We'll give our metrics. Metrics equals accuracy. Accuracy is also given here. Okay. Yes. So it is ready to go. We got a green signal. So what I have given here is basically, so I have given instruction compile the model. The addom optimizer helps the model learn efficiently. So this is the optimizer which I have used here, and binary cross entropy is used because this is the binary classification problem, and accuracy is used to measure performance. So our compiler is ready here. So we have to train our model, and to train our model we'll give our instruction here, model fit in pods. Yes. So what I have given here is I train this model for 100 epochs. During training, the model will start again here. So firstly we'll give model fit will include in our variable x, then our variable y, then epochs equals 100 time. We have given our instruction here. Now I train this model 100 times. So next we'll click on shift enter. Just look at this. So this model is being started to train 100 times. Basically it is learning. Just look at this. From 1 to, from out of 100 it has begun and is learned. Just look at this. Overall total of 100 repetition it's been done. So now we have trained our model. Now we'll make our prediction. After training I test this model with a new values of 5 steady hours. Now we'll give our instruction again. Now prediction, click on this prediction equals model dot predict. So we'll predict 5 numpy in array, then when include this in 5, right. So I have given my instruction here. Lastly I will tell it to print. Print is nothing but to show our prediction. So I think it's done. Now let's run our code. Just look at this. We got our values. So the model has predicted the value 0.5432. So what does it explain? So if the predicted value is close to 0, the student is predicted to fail. If it is close to 1, the student is predicted to pass. This shows how a trained deep learning model can make prediction on new data. We've got our value greater than 0.5, which is very close to 1. So student is yet to pass. This is a simple example of deep learning using TensorFlow and Keras in Google Colab. The workflow includes libraries, preparing data, building the model, training it, and making decision. So this is all about deep learning. I hope you all understood what it means, and I have made easier to understand this. If you like this video, please like and subscribe. If you are having any query, you can just email at this email ID biotech rebioin AI, or you can contact at this number. Thank you for watching.